For 48 minutes, a telescope watched something in the darkness do what no natural object is supposed to do. It blinked. Not like a star flickering through Earth's atmosphere. Not like a satellite catching sunlight. This was deliberate. A clean, repeating dip in brightness like a lighthouse turning its beam away from you. Over and over and over. The team watching the live feed didn't cheer. They didn't celebrate. They went quiet. Because if their measurements were right, this wasn't just another asteroid. And it wasn't even just another comet. It was a visitor from outside our solar system, and it was moving like it had somewhere to be. And then came the part that still doesn't sit right with the people who saw the raw data first. The object wasn't alone. Something else was following it, hidden in the glare and the noise, until China's new observations pulled it out of the dark. In the next 20 minutes, I'm going to tell you the story of the object now known as 3I Atlas. Why China's new discovery about it made scientists whisper the same terrifying word, and the bigger secret that may be riding in behind it. But to understand why this is different, you have to go back to the first time we ever realized the solar system isn't sealed, back to the first interstellar intruder that shattered the rules. Because what's happening now didn't start with 3I Atlas. It started with a mistake nobody could unsee. People think space is empty, quiet, safe. In reality, our solar system is a neighborhood with no fence. Every day we orbit through a river of debris, dust, rocks, ice, left over from the formation of planets, carved by gravity into belts and clouds. Most of it has been here since the beginning. It's familiar. It obeys familiar dynamics. And then, once in a great while, something arrives that doesn't belong. It doesn't loop around the sun like a local. It doesn't return on schedule. It doesn't fit the family tree. It comes in fast. It swings by once. It leaves forever. That matters for one simple reason. An interstellar object is a physical piece of another star system. It's a message in rock and ice. A sample you didn't have to travel light years to collect. But that's not the real news. The real news is what interstellar objects imply about the traffic between stars, and what happens when that traffic isn't random. What you've probably heard is a headline, "Third interstellar object discovered." What you haven't heard is the uncomfortable part buried under the orbital fits, the spectroscopy plots, the late-night calls between observatories. Because 3I Atlas didn't just show up. It showed up with timing, with behavior, and with a pattern that, according to a handful of researchers, lines up with a question nobody wants to ask out loud. What if the thing we've been calling rare is actually common, and we only just became capable of seeing it? And if that's true, how many have already passed us, unnoticed? Hold that thought, because in a moment we're going to meet the first scientist who realized something was wrong with 3I Atlas before the rest of the world even knew it existed. And what she saw on her screen looked, at first, like an error. But then the error kept moving. In October 2017, a small team in Hawaii picked up an object that didn't behave like anything in the catalog. It was faint, fast, and its trajectory was wrong. Wrong in the way that makes your stomach tighten if you know celestial mechanics. Because everything bound to the sun follows a closed path. An ellipse, a loop, a promise that it will come back. This thing didn't loop. It was on a hyperbola, a one-time curve, an entrance and an exit. They named it Oumuamua, a messenger from afar arriving first. It should have been a clean story. An interstellar rock drops in, we measure it, we learn something beautiful, we wave goodbye. Except it didn't act like a clean story. As it left, it accelerated, not much, just enough. A subtle, persistent push that gravity alone couldn't explain. Comets can do that, jets of gas, like tiny thrusters when sunlight heats their ice. But Oumuamua didn't look like a comet, no visible coma, no obvious tail. So the first interstellar visitor left us with a bruise in the scientific community. The feeling that nature had done something clever and we hadn't caught it in the act. 2 years later, in 2019, we got 2I Borisov, and everyone exhaled, because Borisov behaved the way a comet should. It had gas, it had dust, it had chemistry we could recognize, a relief, a reassurance. And then the sky went quiet again. Scientists told themselves interstellar objects were rare, one every few years maybe, a cosmic lottery ticket. But there was a problem with that comforting idea. It depended on one assumption, that we were seeing come most of what was there. And deep down, the people building new telescopes knew that was a lie. Because we've only recently started surveying the entire sky every night with the sensitivity to catch faint, fast-moving things. Meaning, the rarity might have been nothing more than blindness. That's where China enters the story. Not as a footnote, but as a turning point. In the last decade, China poured resources into a new kind of astronomical vigilance. Wide field surveys, rapid follow-up networks, and some of the most sensitive radio and optical instruments on Earth. And then, during an otherwise normal scan, one of those nights where you expect nothing and get exactly that, An alert pinged across an international network. A dot, a streak, a moving pixel. At first, it wasn't terrifying. At first, it was paperwork. The first public label attached to the object came through a familiar pipeline. Automated surveys flagging candidates, humans confirming motion, orbit calculators testing possibilities. Atlas, the Asteroid Terrestrial Impact Last Alert System, has one job: find things that might surprise us, including the kind that could one day threaten Earth. It was Atlas data that pushed the early observations into the system and triggered follow-ups, and the provisional name that began circulating carried that signature: Atlas. But it was the number in front that made professionals sit up straighter. 3I, Third Interstellar, a designation that isn't given lightly because it requires one terrifying piece of math. The object's path must be unbound, meaning it is not from here. When the first orbit solutions came back, there it was: eccentricity greater than 1, inbound velocity too high to be a solar system native, an interstellar intruder, a new messenger. Except one detail didn't fit the comforting random wanderer story people wanted. Because when astronomers backtracked its path, rewinding the orbit like a crime scene reconstruction, they found it was coming from a region of the sky that made several teams uneasy. Not because that direction is alien, because that direction is crowded. It's dense with stars, molecular clouds, gravitational chaos. The galactic plane, where the Milky Way is thickest, and where interstellar debris should be harder to model, harder to predict, and harder to identify. So here was the first question that snapped shut like a trap. If 3I Atlas came from the noisiest, most confusing part of the sky, how did we see it so clearly? And then came the second question, quieter but worse. If it came from a crowded lane, could there be more behind it? The first wave of headlines didn't ask that. They focused on the romance. A visitor from another star. But inside the follow-up teams, a different mood spread. Because the brightness curve, the way the object's light changed as it rotated, didn't look like Borisov. It looked like something stranger. And the first team to notice that wasn't in Hawaii. It was in China during a long night when the air above the observatory stayed steady and the data came in clean. The kind of night that makes astronomers superstitious because you can feel the universe cooperating. A young researcher, someone who had spent years training herself not to overreact to noise, stared at a plot on her screen and felt her pulse climb anyway. The object's light wasn't simply fluctuating, it was repeating. A rise and fall, a rise and fall, a rhythm that suggested the object was tumbling, or rotating, at a consistent rate. That's normal for asteroids and comet nuclei. But the amplitude, the depth of the brightness change, hinted that this thing might be unusually elongated, or unusually reflective, or both. A shape that, in the wrong lighting, could look like a needle. That word, needle, has a history in this field now, because Oumuamua raised the same uncomfortable possibility. Something long and thin, something that didn't fit the classic potato rock expectation. But here's where 3I Atlas took its first sharp turn. When China's team compared optical data with early spectral readings, splitting its light into chemical fingerprints, they expected a familiar story. Water ice, carbon compounds, maybe cyanide bands if it was comet-like. Instead, the signature was muted, not empty, not featureless, but missing some of the loud markers that would have made classification easy. And that matters because interstellar comets should be volatile rich. They come from cold outer regions of other systems. They should light up when they meet our sun. So why wasn't 3I Atlas screaming chemistry the way Borisov did? Was it rocky, like Oumuamua? Was it an exhausted comet, already baked by previous stars? Or was it something else entirely? An object whose surface had been altered by time between the stars, coated in dark material, hiding what was underneath? The Chinese team sent their preliminary notes to collaborators. The response wasn't impossible. It was worse. It was interesting. We're seeing something similar. Now multiple groups had the same itch, and when that happens, you don't sleep. Because the next step is to ask the question that forces you into a corner. If the chemistry is subdued, then what's causing the motion? And that question would explode a few days later when updated tracking data showed the orbit wasn't behaving exactly like a simple gravity-only flyby. There was a tiny deviation, a drift, small enough that you could ignore it if you wanted to, but it kept accumulating. And the people who had lived through Oumuamua felt a cold familiarity, because they'd seen this movie before, and last time it ended with a mystery we still haven't solved. At first, the deviation was blamed on measurement uncertainty. That's the responsible thing to assume. These objects are faint, the sky is messy, the instruments are not perfect, but then the arc of observations grew longer, the error bars shrank, and the deviation didn't vanish. It sharpened. That's when the community split into camps. One camp said, outgassing. Even if we don't see a tail, there could be jets of invisible gas, like molecular hydrogen, that push without obvious dust. Another camp said, radiation pressure. Sunlight itself can push on a thin object, like wind on a sail. That had been proposed for Oumuamua, too, and it opens a door nobody loves because it invites one forbidden phrase, light sail. And then there was a third camp, the quietest one, that didn't publish bold claims, didn't chase headlines, just kept asking a dull, terrifying question. If we can't see the mechanism, are we sure we're interpreting the data correctly? Because if the interpretation is wrong, then the orbit is wrong. And if the orbit is wrong, then the timing is wrong. And if the timing is wrong, then we may not know where it's going, or what it's aimed near. But 3 Boreae Atlas wasn't the kind of object that gave you time to argue in slow motion. It was fast, interstellar fast. And every night that passed was a night it got farther, dimmer, harder. So observatories coordinated like an emergency response. This is the part viewers rarely see, the human network. Emails at 3 a.m., calls across time zones, people bargaining for telescope time like surgeons fighting for an operating room. In China, additional instruments were tasked for follow-up, larger apertures for faint photometry, higher resolution spectroscopy when the seeing allowed, and, most importantly, rapid cadence observations to pin down rotation behavior. And that's when China's team made the discovery that changed the emotional tone of the entire story. Because it wasn't just that 3i Atlas rotated, it was how it rotated. The light curve didn't match a simple spinning body. It looked like a complex tumble, like something that had been torqued, disturbed, or broken and reassembled. Natural collisions can do that. Outgassing can do that too. But the period ratios, how one wobble nested inside another, suggested something that had experienced a violent event not long ago. So the new question became unavoidable. What happened to this object before it reached us? Did it collide with something in its home system? Did it graze a star? Did it get ripped by a planet? Or did it suffer something else entirely in the cold between stars? A place we romanticize as empty, even though it's littered with hazards we barely understand. And then, right when scientists were busy looking backward, searching for an origin story, the data forced them to look forward. Because 3i Atlas had an appointment, a closest approach, a brief window when it would be at its brightest, its easiest to study, and, depending on the true orbit, potentially closer than anyone liked to admit out loud. The countdown began. And with countdowns, fear has a way of creeping in, even when the numbers say you're safe. Because numbers don't comfort you when you don't trust what's pushing the object. And we still didn't know that. Not for sure, not yet. But then, something appeared in the frames that wasn't part of the main nucleus. A smudge, a ghost. And it was moving with it. At first, the smudge was dismissed as a background galaxy, then as a processing artifact, then as a nearby star blended in the field. But it kept showing up in different images, from different nights, from different instruments. Not always visible, not always clean, but persistent enough that one analyst in China did what analysts do when they're trying not to panic. They stacked the frames. Stacking is a trick. Align images on the moving target, combine them, and anything traveling with the target becomes clearer while the background smears away. When they did that, the smudge didn't smear. It sharpened, not into a crisp second object, not yet, but into something with structure, a faint extension, a trailing feature that looked less like a background coincidence and more like material. A tail? But if it was a tail, why had the spectra been so muted? And if it wasn't a tail, what was it? The results were shared cautiously, no dramatic claims. Just a note, there may be associated debris. Then other teams tried the same stacking approach, and the feature appeared again. A weak, elongated glow offset from the nucleus, a line not perfectly away from the sun like a classic dust tail, but slightly skewed. That skew matters, because it can indicate particle size. It can indicate emission timing. It can indicate fragmentation. Fragmentation is common for comets. They break, they shed pieces, but an interstellar object fragmenting near the sun raises a bigger, darker question. If 3i Atlas is shedding material here, how much did it shed before it got here? And if interstellar space is filled with fragments from other systems, could Earth have been hit by one in the past and never known it wasn't local? This is where the story stops being just astronomy and starts becoming something else. A story about contamination, about biological possibilities, about the thin membrane of our atmosphere being the only thing between us and the wider galaxy. Because if fragments from other star systems enter our sky more often than we think, then the exchange of material between planetary systems might be routine. And that means the exchange of chemistry might be routine. And that means, whether you love or hate the idea, the exchange of prebiotic ingredients or even microbial life, becomes a question you can't laugh away anymore. This is called panspermia when it's treated academically. But to the human brain, it translates into a single unnerving thought: we might not be alone in our own origin story. However, that wasn't the terrifying part China's team couldn't stop thinking about. The terrifying part was geometry, because once you accept the possibility of associated debris, you start checking something else. Are there more objects on similar trajectories? Are we seeing a single wanderer, or are we seeing a stream? So they did what modern astronomy does best. They cross-referenced. They went back into survey archives, months, even years of old sky scans, looking for anything that might have been missed, anything moving too fast, too faint, too weird for an algorithm to confidently flag. And in those archives, deep in the noise of earlier images, they found a candidate, a faint track, not enough to declare discovery, not enough to publish a headline, but enough to ask a question that makes your skin prickle. If 3i Atlas was in our data earlier than we thought, how many more are in there? And why are we only noticing now? The answer, if it's true, changes everything. Because it doesn't just mean the universe is throwing more rocks at us than expected. It means we've been living inside a rainstorm and calling it clear weather. But then, the orbit solution updated again, and it got worse. When enough observations accumulate, you refine the orbit. You don't just know where it is, you know where it will be. Unless something is pushing it, and that's the part that kept refusing to behave. The updated fit suggested a non-gravitational component that didn't align cleanly with a simple jet away from the sun model. It was subtle, but it nudged the predicted position enough that observers had to adjust pointing. Telescope time is precious. You don't like chasing a target that won't sit still where the equations say it should. And that's when someone asked a question so basic it felt insulting. What if it's not one body? What if what we're tracking as the object is a changing center of light, a shifting brightness distribution because material is being emitted irregularly? In other words, what if the wobble in the orbit is partly an illusion created by a messy, evolving source? That would be comforting, because it would keep the explanation natural. But it would also mean something else, that 3i Atlas is more active than it looks, and simply hiding its activity in wavelengths and particle sizes we're not capturing well. China's observers pushed for multiband coverage, trying to catch faint emissions and constrained dust properties. They coordinated with infrared attempts where possible, because infrared sees heat, and heat reveals jets that optical light can miss. And for a moment, the data hinted at a breakthrough, a slight excess consistent with warm dust. Not a screaming coma, a whisper, just enough to say, yes, something is coming off the surface. Relief rippled through parts of the community, outgassing, natural, end of the scary story. But science doesn't reward relief, it rewards what survives the next test. And the next test was the rotation, because if outgassing is strong enough to push the orbit measurably, it often changes the spin over time, like a thruster changing a spacecraft's attitude. So teams compared early light curves to later ones. The pattern had shifted, not wildly, but enough. A drift in the tumbling behavior that suggested torque, that supports outgassing. Another exhale. Except China's group noticed something else at the same time, something that didn't fit the relief narrative. The brightness dips, the blinks, weren't just drifting, they were intermittently sharp. As if, during parts of the rotation, something on the object's surface was dramatically different. A patch of higher reflectivity, or geometry causing sudden occlusion. A crater? A ridge? A slab of exposed ice? Or a shape that isn't smooth, that isn't eroded by billions of years, but instead looks engineered in the way only a paranoid brain would say out loud? They didn't say it out loud. They wrote careful words. Anomalous photometric behavior. But the human mind is not made of careful words. It's made of images, and the image that spread quietly through late-night chats and private messages was simple. A tumbling, elongated visitor from another star, with a repeating signal in its light, with faint debris that might be traveling with it, and with a trajectory that brought it into the inner solar system at the exact era when humans finally built the tools to notice. So here's the question that turns a scientific puzzle into a goosebump story. Is it coincidence that we're seeing more interstellar objects now? Or is something changing, our instruments or the sky? Because if the answer is the sky, then we're not just better observers. We're witnesses to a new phase of our solar system's life. And we may not like what that phase brings, but this wasn't the biggest surprise. The biggest surprise came when China's deeper analysis focused not on what 3i Atlas was doing, but on what it might be carrying, and what that could mean if even a fraction of it reaches a planet like ours. Spectroscopy is where romance goes to die and truth is forced to speak. You split the light, you measure absorption features, you compare to libraries, you estimate composition. And for days, the results stayed frustrating. not clean enough to declare a simple identity, not strange enough to claim a revolution. A liminal object, half familiar, half hidden. Then a new dataset came in under unusually good conditions, better signal to noise, wider wavelength coverage, cleaner calibration. In the Chinese team's preliminary reduction, a few features stood out more clearly than before. Complex carbon-bearing compounds, the kind of chemistry that in our own solar system tends to cluster around comets and outer system bodies. Organics, not life, not a microbe waving from the void, but organics, the building blocks that, given the right environment, can assemble into much more. That would have been a beautiful story on its own. Another star system's chemistry visiting ours. Except beautiful isn't how the team described the feeling in the control room when they realized what else those features implied. Because if those compounds were real, and if the object was shedding dust, then 3i Atlas wasn't just passing through. It was sprinkling. Tiny grains pushed by sunlight and time, released into the solar system like seeds in the wind. Most would disperse into nothing. But not all trajectories are equal. Some dust becomes meteors, some becomes micrometeorites, some spirals inward, some collides. And that takes us to the part of the story nobody puts in the headline because it sounds like science fiction until you realize it's just physics. Interstellar objects don't have to hit Earth to matter. They only have to leave something behind that does. Now, to be clear, there is no evidence that 3i Atlas is infecting anything. That's not how responsible science talks. But the terrifying implication isn't about infection. It's about exposure. It's about the fact that the solar system is not a closed laboratory. It's an open system, trading material with the galaxy. And if that's true, then every question about Earth's uniqueness gets harder. Are our building blocks local or borrowed? Is life here a miracle or a standard outcome when chemistry is shared across stars? And if chemistry can travel, then what else can travel? At this point, a sensible viewer might ask, why is this terrifying instead of inspiring? Because the same mechanism that carries organics can carry hazards. Not just biological hazards. Again, we have no evidence of that here. But physical ones. Impacts, airbursts, and the blunt reality that we are not the biggest thing in our own neighborhood. Atlas exists for a reason. And the reason is that the sky occasionally throws punches. But interstellar objects are a special kind of punch because they come in faster. They give less warning. And they don't follow the familiar families of orbits we've mapped for decades, so the international tracking effort tightened. Predictions were updated, closest approach distances were refined, and the public-facing language stayed calm. Because calm is what you project when you're still measuring. But behind the scenes, another question had started to dominate the most private conversations. If 3i Atlas is one of a larger population, what happens when the next one isn't faint? What happens when the next one is big? And what happens when the next one isn't found months out? But days? This is the part where stakes escalate from scientific curiosity to planetary policy. Because if interstellar objects are more common than we believed, then the entire framework of impact monitoring changes. Our warning systems are tuned for local threats with local speeds and predictable orbital neighborhoods. A truly fast interstellar object could appear late, brighten quickly, and slip past the inner solar system before we even finish debating what it is. And here's the most unsettling twist of all. If China's archival search really did pick up a pre-discovery trace, if it was there, hiding in data we already had, then our vulnerability isn't just about telescope power. It's about attention. It's about the fact that the sky has been talking for a long time, and we only just started listening properly. So when 3i Atlas reached its brightest phase, the world's observatories leaned in like an audience at the edge of their seats. And that's when the blink returned, stronger, cleaner. And briefly, for a few hours, it looked like something that could be interpreted as a signal, not a radio transmission, not a message in English, a signal in the only language celestial bodies always speak, light. And it forced the oldest question in astronomy back onto the table, heavy, unavoidable, and still unanswered. Are we watching nature? Or noticing the edge of something else? The final answer didn't arrive that night, but something did. Something that made the Chinese team stop thinking about 3i Atlas as a single event, and start thinking of it as a warning. Because as the data poured in near peak visibility, that faint trailing feature, the suspected debris, didn't just persist. It evolved. It separated into what looked like multiple condensations. Tiny clumps, each too faint to confidently label, but collectively suggesting the object was shedding pieces in a structured way. Fragmentation events happen in comets. Yes, but fragmentation in an interstellar body is a different kind of clue. It implies internal structure, layering, stress history, perhaps even a rubble pile assembly. And with that, the new fear wasn't, this is artificial. The new fear was simpler and arguably more realistic. If interstellar objects can fragment in our inner solar system, then what we call one object could become many, a stream, a shotgun blast of small bodies rather than a single bullet. Most fragments would burn up, some would become fireballs over empty oceans, but it only takes one fragment at the wrong time, over the wrong city, at the wrong altitude, to rewrite history. That is not fear-mongering. That is the math of kinetic energy. And it's the reason that when 3I Atlas became a global observing priority, it wasn't just because scientists wanted to satisfy curiosity. It was because the object forced a rehearsal for the day the intruder isn't cooperative, a rehearsal for the day the orbit isn't well constrained, a rehearsal for the day we have to decide what to do with something that doesn't belong here and doesn't care that we're fragile. So where does that leave us? If you came for a clean ending, it's just a comet. It's definitely not. Case closed. The story won't give you that. Not yet. Because the truth is that interstellar objects live at the edge of our capability. They appear quickly, vanish quickly, and every measurement is a compromise between time and precision. What China's new observations did wasn't prove aliens. What they did was more unsettling. They made the natural explanations bigger. They made the population question unavoidable. They made the debris question real. And they strengthened the case that the solar system is being visited more often than our cultural instincts are prepared to accept. So let's return to the first image. A telescope watching a repeating blink in the dark, a scientist trying to convince herself it's noise, a graph that refuses to be broken, and a name that carries a quiet threat in its first two characters, 3I, third interstellar. Not the first, not the second. Third, which means no matter how you interpret the chemistry, the tumbling, the faint fragments, one thing is already true. This is a pattern. And patterns don't stop on the number 3. Somewhere out there, in the same crowded lanes of the galaxy that delivered 3I Atlas, there are more pieces in motion. More messengers, more debris, more unknowns. Some will pass harmlessly. Some will teach us what other star systems are made of. And one day, whether it's a century from now or sooner than anyone wants to admit, one will arrive that doesn't just make scientists whisper. It will make governments move. Because the terrifying secret isn't that 3I Atlas might be unnatural. The terrifying secret is that it might be completely natural. A normal part of a galaxy that is not empty. A galaxy that trades matter like breath. And if that's the universe we live in, then Earth has never been isolated. We've just been lucky. And luck is not a strategy. So the next time you look up at the night sky and it feels calm, remember this: the darkness isn't still. It's full of travelers. And now finally, we're building eyes that can see them coming. The question is whether we'll build the wisdom to understand what we're seeing before the next messenger arrives first.